At this point, my racing game is basically done, although it just exists. It's not quite ready yet. I want more. I need this game to feel like driving. And I've added a few elements already. I have screen shake and sparks and cutscenes, but I need a little bit more. The first element I added to make this game feel like a race is track records for each track. These track records I built feature the fastest lap time and the fastest race time for each of the tracks that are possible to drive. I'm only making 3 tracks. I'm okay with that. It doesn't have to be any more. So when the player selects a track, the hope here is that the player will naturally try and get faster and faster. The way I did this was with a couple of variables. If we get out of full screen mode here and look at the save variables in flow graph, might be easier to see them in the full screen. I did have to make variables for each track, 2 for each. So I've got a best lap time and a fastest race, and those are each called in succession at the end of the race. So another thing about that is sort of a protection. Let me load up a track here. We'll go to drift track first. The records are both set at the very end. It's called last, so that way the player has to complete the race for that track before it will credit them with these successes. So it's not like you can do 1 lap and then quit. That wasn't the design I wanted to go for. And all it does is just go into a branch and say if it's the fastest race, then set the fastest race. If it's the fastest lap, set the fastest lap. Kind of simple in theory, but there's actually a kind of neat way I did this, where off the branch coming off the play the victory sound, there's a true-false branch there, and if the race time is less than your fastest track, it's going to set the saved variable for your fastest race, and it's also off that executable going to go into another branch which takes the false from the prior branch. So no matter what happens in the flow, that second branch is always going to trigger to set the best lap time as well. And by similar fashion, it's going to, if the race is 0, that's what that 0 float indicates. So if it's the first time the player is ever racing this track, it's going to say, okay, no matter what your score is, if it's equal to 0, it's also going to trigger that branch to set the fastest race and or fastest lap time. And it's just a very simple get the save variable and get the scene variable and compare them together. Real simple. If one's greater than the other, it's going to set the drift track or a corresponding track to the best lap. And it's as simple as that. That's all it's going to do. In the garage scene and the UI elements here, we've got the race, and we can see that there's the best lap and here's the fastest races. And all these do is they grab the variable, which it's going to grab the selected scene variable. I did that on purpose because once you click on a track, it changes the variable in this scene to something called selected scene, and that's also what plays when you hit the play button. And then it's going to find the game object for the best track lap, which is where these variables live. So it's not in the best lap time, it's actually in the track select. It's kind of a cool way to do it, I think. Got to go open the scroll view and the viewport and the track selector. So there are these variables here for each of the tracks. So we've got speed test, leg track, and drift track, and they each have this variable to pull from. So that way I could keep the flow graph a little smaller on the back end. This is kind of a new trick I've learned with visual scripting. So I've got the track to load, I've got the best track lap, and the best track race, and these are actually named variables. So check this out. This is actually kind of a cool way to do this. If I go to the best lap time, here it is. It's going to find the object of the selected scene, and it's going to pull that object's best track lap. And then since that's a float value, it's going to have to do the math. This is the exact same math that we use to determine the track time. So it's going to count up in terms of a float value, right? So from 0 to 100. But because it's time, I need to divide by 60 and then go with the math function floor to int and then plug that into the string variable. It's not a variable, it's a string format. So that way when it formats itself into the text message pro unit, it's formatted in that 00:00:00. This is actually it. This is the entire flow machine right here. This is going to pull the best track lap, which is the same as the best track overall race. It's virtually the same function. So here's the best lap time. We're going to switch this over to best race time, and I'll expand this one out. It's the same function. It just grabs a different variable, best track race, from that object. Formats it the same way. This is a very clean and easy way to do it. It changes that float value into basically like a race timestamp, plugs it into the text of self, and calls it a day. It's very simple, very easy way to do it. I also wanted to add a function in this game to hide the mouse if the player was using like a gamepad to play the game or not using the mouse at all. I wanted the mouse cursor to disappear. I did that by adding a quick function to test whether or not the X and Y values of the mouse had changed every 2 seconds, otherwise the mouse would fade away. So it looks something like this in the game. I'll just play it in the game window here. We'll skip the cutscene. You can see my mouse in the middle, and if I wait, it disappears, right? And we're actually looking at the flow graph in real time for how it works. If I move my mouse, it's going to come back. And it's going to say, okay, are we moving the mouse? We can see it firing right now. It's going to set it as visible. And if I stop moving the mouse, it goes away again. So let's check that out. We'll full screen this graph. It's going to be off the update event, which is also a coroutine. So if we check out the graph inspector, you can see I've checked the box for coroutine. And then we just plug that into a while loop. And all we need to do is get input axis both mouse Y and mouse X, and if they're equal to 0, which is those Boolean values that we see just coming off the same int 0, which doesn't have to be a variable at all, it's just a static int 0. And what we want to do, instead of a Boolean, we want to do an AND. So that AND value is going to say if A and B, then plug that into the while loop. And so if A and B are 0, then we're going to delay. We're going to wait for seconds, which is 2 seconds, and we're going to check that unscaled box right there, which means if the game time is set to 0, in other words, if the game is paused, this function will still apply because it's in real time, not in game time. Hopefully that makes sense. So that way, if the player does have the game paused and they stop moving the mouse, it'll disappear. In the exit half of that while loop, it's going to set the visibility to true. It's also going to wait 2 seconds, and then from that executable go into the it's going to reset that once function on the body loop to wait after the wait 2 seconds into a once into a set visibility. If you don't have a once function, or if you don't have a once node right there before the visibility is set to false, the mouse ends up kind of flashing a little bit. So what I had it do is wait 2 seconds, then set the visibility to false after 2 seconds, and then reset that once node after the mouse has become visible. The next thing I wanted to tackle was the car AIs. So I spent some time making an AI for each of the cars. So there's a blitz car, a pickup, a Porsche car, a rally car, and a sports car, and they're all AI cars. I don't know yet if I want to do 4 or 6 total cars racing. 6 seems like it's a little more chaotic than I would like it to be. So on this track, I currently have 4 cars racing. None of them are the fastest car. So on this track, we have rally car, blitz car, and Porsche car. I'm going to change the names in the final release of the game, but for now, those are the working titles of each car. So on each car, I've added a variable. So I'm using the same technique where I've added a variable called body material. This is on each prefab. Every single one has it. Every car has to have its own material, so that way I can change the color of them independently. Here's what I'm thinking. First, no car will have the same color that the player has chosen. Okay, so that's going to be the first element of game feel that makes the player feel unique. Secondly, no AI car will have a color that the player cannot choose. Does that make sense? So I'm not just going to a random color, because then the player is going to see a color on a different car and say, I want that one. Why can't I have that one? So again, in the race manager, I'm controlling this by calling it at the start. The first step is I made a scene variable which houses every possible color, and I just named these. I added this to a list, and I got them by their RGB 0 to 1 values. This was a lot more accurate than any other option to pick the colors, and I simply made a list of colors. So what this is going to do is flow through for each color in this list. It's going to compare that to the saved body color that the player has chosen, and if they are equal, this is the Boolean that we're going to plug into that branch value. So it's going to say if they are equal, then set the graph variable to player color. And what I want to do next is say on the exit flow from this loop, we're going to drive out to remove that item from that list. So we're going to take the colors list and remove the player color from it. So this all happens first. And this happens very quick. This is a split second. Once we remove the player color, well, then we're going to go on to set the AI car's colors with a random value in that list. So here's how I did that. First of all, I had to tag all of those prefabs with the term AI car, and then take that list of tags. We're just going to find objects with tags. Very important, we don't find object with tag. That node must say find objects, plural, with tag. Then we plug that into another loop, and so it's going to loop through each of the AI cars in the scene. It's going to grab the object variable body material from each object in that list. It's going to take that material and set its color to a random value from the colors list, and it's going to get a random range of 0 to however many colors are in that list. Okay, so it's going to count the items and go 0 to that many. It's going to get that item's index and then remove it from the list. We're going to go full screen here and hit play. And I've added a skip option to my cutscene, which just skips ahead a little bit to the part where we zoom in, and we can see right here that all three AI cars have a different color. My car is still blue, and the Porsche car is red. He's giving me some grief. Got a white Blitz car and another yellow rally car. So it works pretty well. And so you can see the player could also see in this method a car of a different color they might like or don't like and don't want to buy it. In this case, the character is actually your car. There is no like playable character. There's no humans at all. It's just cars. So for a game like this, I think it's important to have that different visual, that different car stat that you can select in the track in the garage scene view. It's all kind of relevant to how the player plays through a game like this. This video here is what made everything possible. This is a video of how I set up the track and kind of gave myself that future-proofing, that forward-looking methodology of creating tracks in AI and kind of fitting everything into a system. So if you want to check out that video, it might be kind of beneficial. And thank you so much for watching.